Hello and a warm welcome to a brand new podcast series brought to you by the Operational Technology Cybersecurity Center of Excellence under the Global Cybersecurity Forum and in collaboration with Saudi Aramco. My name is Rebecca McLaughlin-Eastham, and I'm delighted to be your host for this series, in which we explore how industries can protect the systems that power our everyday lives from evolving cyber risks, drawing insights from global experts at the forefront of operational technology and industrial control system security. Today, my special guest is Andrew Kling, Director of Cybersecurity and Architecture at Schneider Electric. Andrew Kling from Schneider Electric, it's wonderful to speak to you today. Thank you so much for talking to me.
Thank you, Rebecca. Nice to be here.
At Schneider Electric, you've long emphasized embedding cybersecurity into systems right from the very beginning. Tell me how this approach really strengthens resilience in industrial control systems, or ICS.
Right. So, there's probably two significant points in Secure by Design, I think, that are important to understand. One is it's a shift left principle. The idea is not to compensate once you find out that a system is vulnerable, but you anticipate and push left earlier and earlier in the development process as the systems are being imagined. So Secure by Design takes into account right from the beginning the needs for cybersecurity. The second point, and I think that this is one that the industry could really lean into and probably improve in, is Secure by Design does ask us to look at threats. It does ask us as OEMs, it asks us as asset owners, it asks us as system integrators, it asks us all to look at the threats that we're aware of and to compensate for those, to address those threats earlier and earlier in the process. Take them into account when you're imagining the system, when you're architecting the system, when you're deploying the system, when you're using the system.
As we increasingly see the convergence of IT and OT, what new vulnerabilities do you see emerging, and how can industries today, including the ones that you work with at Schneider, really address them best?
Yeah, when I think about the convergence of OT and IT, sometimes it's very comfortable for us to slip into thinking about this convergence as, oh, we're going to borrow technology from the IT world and apply it into the OT world. And yes, there is that off-the-shelf type solution that is very attractive, and that certainly is part of IT-OT convergence. But really, more fundamentally, IT-OT convergence is about the speed of business matching up with the speed of process control to allow the business to understand the pace that operations runs at, and operations to understand where the decisions are that the business needs to make. And how does that start to expose us? What sort of vulnerabilities start to get exposed through this IT-OT convergence? Well, certainly it starts to change the nature of the attack surface. It starts to say if you wish to disrupt the business, it isn't just maybe about disrupting a logic controller, logic functions from being processed, maybe disrupting, a PLC somewhere. Maybe it's about disrupting the decision that the business has to make or influencing a decision that the business has to make. So it changes the nature of the attack surface. No, I'm not saying necessarily that it changes the attack surface. There is always that element of, well, if the business and operations are now going to integrate, we need to worry about that interconnection between the two pieces. So there is that element of it. But I would just say that we need to be very cognizant of the fact that it's this nature of the attack surface that really starts to evolve, that really starts to change. And that changes the nature of the risks that we need to be aware of.
Tell me, Andy, in high-stakes environments like energy, water, and manufacturing, for example, as we know, downtime can be both costly and disruptive. So what does resilience really look like in those contexts?
Resilience really looks like keeping operations up and running. That's most fundamental. And quite frankly, when we're looking at risks to a system, that's what we're thinking about. It's not always we're trying to protect this logic control, this flow of data, but the overall thing that we're trying to protect is to keep that business functioning, to keep those operations operating. By understanding the system, you'll understand the objective of the system and know that that's really what you're trying to protect.
You touched a bit upon it when we spoke about the nature of attacks and how the landscape is evolving. Obviously, they're increasing in size, sophistication, and scope, but let's do a deeper dive. How exactly do you see the landscape having changed over the past decade, and what new challenges do you foresee on the horizon that we should be aware of?
Yeah, this is a great question, one that I'm always anticipating. We all understand that the nature of the attack surface is changing because of artificial intelligence. But in recent years, we've seen the absolute explosion of IoT, the absolute explosion of the ability of data to flow, that connectivity that connect to the edge. We've seen an absolute explosion in the amount of data that is moving, and we've seen an absolute expansion in somewhere to store that data. That's the cloud. So improvement in compute at the edge and the lowering of cost has resulted in an explosion of IoT, which is a concept that we're well familiar with in this OT world as industrial IoT. We've seen that connectedness really change the nature. And when you think about all of this, when you think about suddenly there's all this compute capacity that's out at the edge, and we're trying to figure out what best to do with all that compute capacity and all of this data that's being generated and all this data that's flowing backwards and upwards, whether it's through historians or operator data, but all this data that's flowing upwards now and being captured. This is the very engine that has enabled artificial intelligence. I could see the potential when I was getting my master's degree in artificial intelligence a long time ago. But what we were hindered by was the lack of access to data and the raw compute power needed to be able to process that data. What's next on the horizon? Well, it's easy to say it's quantum compute. Nobody really knows when quantum compute's going to happen. The challenge really is to get past the marketing spin, see how the technology is evolving. Quantum compute is driving two things. One, it's going to drive a very nature of computer science to evolve, which is fascinating and exciting all at the same time. In this evolving of computer science, quantum compute is going to bring the ability to solve classes of problems that definitely weren't easily solvable through the traditional binary compute approach. I think that artificial intelligence is a byproduct of all of this enablement of this compute infrastructure that I talked about. I think that quantum compute is going to change the nature of the kind of problems that we're going to be able to solve. All I can say is there is a lot of resource around the world. Every region, every country, every government agency is thinking about quantum compute and pouring energy into it. As a result, there's this whole realm of computer science, this whole realm of regulation, this whole realm of cyber standards that is preparing for this era of quantum compute. So this post-quantum era, and we're all getting ready. And this is bringing new challenges. So when we look forward, what's going to happen in 2026? What's going to happen in 27? What's going to happen in 28? Even the preparedness we have before quantum compute happens is causing things to change. The nature of quantum compute and getting ready for it, one of the things that you do is you want to bring to bear quantum resistant encryption algorithms. Well, that whole inventory of encryption across a vast industry of products and systems is actually a big problem to solve, to understand where it is. And then that brings crypto agility, the ability to change ciphers based on the situation you're in. Whether that's a regional encryption standard that you have to adapt to, or it's a post-quantum compute era driver that's moving you towards getting ready. A lot of what's changing in our near future is going to be getting ready for post-quantum compute. I think people are really starting to see that the nature of software engineering is changing because we can now start to build into AI some of that heavy lift capability. We always talked about years ago Pareto's rule, 80% of something takes 20% of the time and the final 20% takes 80% of the time. Well, that's what's going to happen now. So instead of saying I have this new idea for this new solution, or I want to evolve this existing solution, and you have to have experts to be able to do your data design, your network design, your software design, we're going to be able to use AI for all of that. I'm not just talking about coding. I'm talking about software engineering. I'm talking about engineering the solution, not just writing the code. To go from requirements to test and all those steps in between, that software development lifecycle, that's something big that's going to change. That is changing. We're just at the very dawn of that capability. If you project your mind 10 years into the future, 20 years into the future, and you see how far we've come in the past 5 years with generative AI, this use of AI to do this software development, and you project that another 20 years in the future, you can imagine the significant changes that are going to take place. That was a long answer, but it was a great question.
Well, thank you very much. Andy, I'm going to move on to standards in just a minute because I'd love to get your take on that. But looking firstly at that imagined or the imminent future that you've painted a picture of as industries are increasingly becoming interconnected, how should leaders reimagine their approach, or how do they become more agile and adaptive, staying ahead of those attackers?
Wow. Okay. So everything I just said can be used for the good. Everything I just said will be using these technologies for their gain. Those who have the most to lose are the people who then have to be adopting or evolving the quickest. The defense industry base, the financial industry, oil and gas industry, critical infrastructure around the world, healthcare. These are all industries that have the most to lose should a cyber attack happen. So it is incumbent upon those who have the most to lose to be evolving the fastest, to be looking to say, what is my use of encryption? If it's true that there's the potential that this encryption algorithms that we're using is broken in 5 years and 10 years, how do I get ready for that? Am I asking my supply chain, the encryption that you're embedding into the hardware, into the devices, into the software components, into the databases, into the network algorithms, all of the technology that I'm acquiring through my supply chain, are you asking the right questions, looking at what these changes, what this potential of these changes has to come? So I think that, there's a lot for us to look out for as OEMs, to anticipate what our customers are going to be using, for our customers to be asking us, to be asking industry. I think there's a lot of conversation for us to be having here now. And by the way, there are a lot of conversations going on right now. I can't say that they've necessarily reached mainstream, but certainly within cybersecurity circles, these are some of the most common discussion points that we have out there.
Well, speaking of conversations, especially the ones that we'd love to be privy to, you're heavily involved in standard development, and we'd like you to take us behind the scenes of those conversations and your involvement, not least with the ISA, because Schneider, of course, aligns with frameworks like IEC 62443. And my question is, how do international standards really serve to strengthen cybersecurity right across industries? And there must be gaps. So where are they?
I work with ISA. I also work with IEC. So we've come together as development organizations to join in developing the cybersecurity standards. So the cybersecurity standard that I work on is called 62443. It is a suite of cyber standards, meaning that there are multiple parts to it, representing different perspectives, uses of cybersecurity, the different roles that are out there, whether it's integrators, or asset owners, or OEMs, et cetera. So the conversations are always around continuing to evolve the standard, to keep it relevant, to keep it up to date, to keep it useful. Securing the supply chain is a group that's spinning up right now. There are conversations going around secure by default. It's a conversation that's been going on quietly for years, but now is starting to really sort of find its footing. It's found its place into regulation. That Cybersecurity Resilience Act out of Europe calls for secure by default. It's a subgroup within the SDL team that I co-lead, and we've tackled secure by default. And I'm on a campaign now to vet something like that around the world, to really try to get governments to weigh in, to get asset owners to weigh in, to get OEMs to weigh in, system integrators, everybody who's going to be called upon to drive their systems towards a default state that is secure. One of the challenges that we've had as an industry is that the 62443 standard is followed by all the OEMs. And the 62443 standard for those OEMs tells us, evaluate the risks, build your threat models, understand what cyber capabilities you need to put into your product. And it goes out, and in different parts of the standard, it will tell us some of the capabilities that we need. And so through this whole interaction of risk awareness and threat modeling and the secure development lifecycle that we follow, we build the products that are securable. We build these capabilities into products and into systems and into services. But nowhere does the standard tell us as OEMs, enable these capabilities. So what we often find is products go out with these capabilities built into them, but it becomes heavily dependent on the asset owner and the integrator, the people deploying the solution, to assess risks and turn those capabilities on based on the risks that they identify. And that created sort of this unbalanced equation. That's an example of one of the conversations that's going on. And there are dozens of conversations going on with very bright people around the world every day of the week as we push these standards forward. In some cases, we're talking with those people doing the mapping so they understand what we have so they can map to it. It's very interesting conversations. It's probably some of the highest level of activity I've seen in standards development in a few years. CRA is really driving a lot of activity. We had one team that would normally have 12, 20 people attending. They rolled out the meeting invite for that team recently, and suddenly we're up in the 40, 50 attendees for standards development, which is a lot. That's a lot of people. It's a lot of opinions to weigh through, but the 62443 standards that are most valuable are what's called consensus driven. And the more voices we have, the higher degree of consensus we're going to have across the industry. So it's all good.
It's all good, Andy, as you say, but given today's interconnected supply chains and critical infrastructure, international collaboration in OT security is increasingly rising to the top of conversations. So, understanding that cybersecurity has become a geopolitical imperative and that there's been a rise in region and country specific cybersecurity regulations and policies in recent years, how can organizations best maintain a secure posture?
Certainly on the defensive side, we're aware of the tactics and techniques that are used out there. So it's a complex question. I do this talk. I've done it probably 40, 50 times over my career. That's entitled The Six Drivers of Cybersecurity. And basically, what I'm trying to do is get past the why does a cybersecurity program exist? We normally would, our gut reaction is to say, fear of attack, fear of attack. Okay, I don't understand what that means, other than the obvious, of course. But it breaks down the conversation into, okay, cybersecurity programs exist because we have regulations to conform to. We have threat awareness. We have customers making requests. We have industry standards, back to the standards discussion. We have the insurance industry stepping up and saying, that there is a certain cyber posture we expect you to maintain if you're going to maintain that transference of risk policy with us. So these drivers sort of help us understand at a deeper level, a more measurable level, why cybersecurity programs exist and what we're trying to accomplish with them. So I think that there's a lot that can come out of really sort of digging deep into why are we doing this? I talked a moment ago about threat awareness. Okay, so that ties to that one driver around being aware of threats that I just talked about. I talked about regulatory compliance with Cybersecurity Resilience Act, and that whole CRA is just generating this awareness around the world, across the industry of, okay, we have to get ready, we have to get ready, we have to get ready. There's all these things that we have to do. And Schneider Electric, where I work, is no different. We're getting ready. Where our products have gaps, we're filling in those gaps. And so this retrospective, as we think about, you mentioned borders, the government or the regulatory bodies within those borders, they're forcing us to go through this retrospective, to analyze, to assess, and to produce cyber defenses that matter, that meet the regulatory needs. Those regulations are meant to answer the cyber needs of today. It will remain to be seen if they will stand the test of time. It's about the ability to influence, I think, that starts to tie some of this together. For many years, we as an industry have been trying to influence government agencies, trying to help us get that driver that pushes us forward. And I don't mean just OEMs, I mean across the industry, getting the government awareness so that governments can come and aid the industry. With cybersecurity, cyber attacks, these are extremely complex topics that are layered on top of complex technologies and complex systems. So the conversation has taken a long time to gain progress, to get to where we are today. Cybersecurity industry standards we can influence because we have been here for years, decades in some cases, getting ready for these conversations, trying to bring these consensus-based cyber readiness to the world. Now, we have been doing this successfully across the industry. We're all using these cyber standards, and the 6443 standard in particular. We make up a very large, influential voice that governments have started to learn how to listen to. It's taken skill at the government level to rise to be able to hear and understand what we're saying.
Looking back, you've mentioned that your passion for AI stems from long, long ago. You've also had decades in software development and more than 20, of course, at Schneider Electric. So I'm keen to know what lessons really stand out to you looking back over the years.
When I first got involved with cybersecurity, they didn't call it cybersecurity. There was no job for me that was cybersecurity. There was a conversation that was starting. It's been quite a while, at least 25 years ago. And those lessons that I take from the beginning, where there was just a small team that was doing cybersecurity on delivery side, that was delivering some of the Microsoft capabilities that was available at the time, Active Directory, if you're familiar with it. But it was relatively small conversation left to just a few people. I used to know everybody involved in cybersecurity here at Schneider Electric. I used to know absolutely everybody. And there is no way I can possibly keep track of everybody that's involved in cybersecurity right now. I will tell you, part of my job is to run the technical cybersecurity community here, complement to the work that we do that spans the entire cybersecurity workforce. Cybersecurity is becoming more and more and more important. When you think about cybersecurity, you should always be thinking about quality of the solution, quality of the system. Cybersecurity helps us build higher levels of quality into our product. So I think cybersecurity is really important from that perspective. Lessons learned are really tied to how do you get cybersecurity to happen? How do you make it happen? Because it's very easy to stick your head in the sand and say, not today. I didn't get attacked today. I probably won't get attacked tomorrow. I can delay focusing on cyber risk and addressing cyber risk until next week, next month, next quarter, next year. Remember, we're all tied to budget cycles, and there's always competition for those resources, for that budget. So how do you get cybersecurity to be important enough to be in that top 1, 2, 3, 4 priorities so that you can address it? I think one of the biggest lessons learned is to have the cybersecurity conversation in the language of those who control the resources, those who have to make the decisions. Don't have the conversation with them in technical terms. You need to worry about this protocol. It's got a CVE that's just been reported with a proof of concept exploit available. You're just going to get blank stares. Instead, have the conversation with this part of the system is vulnerable. As a result, this train will go down. As a result, the loss of production may add up into millions, billions, whatever the number is, that is your measure. But have that conversation in the language of the business. I think that's one of the key lessons learned. I got one more lesson learned that's completely different, but maybe it isn't. So when I was first working on scaling cybersecurity, this is when I worked at Invensys, which was acquired by Schneider Electric. The challenge I had was, how do I get the attention of those project leaders? How do I get the attention of those product owners so that they can make cybersecurity a priority in their development process? For 2 years, we were getting very low compliance to our cyber program, 10, 20% compliance. Terrible. And then I had this idea because I came from product development, so I know how product development works. I had this idea of stop talking about cybersecurity as a standalone topic. Instead, get all of the work that you have to do for cybersecurity planned in where all of the other planning takes place. So plan cyber work right along with all of the other work. Now that sounds rather obvious and rather intuitive, but it was a breakthrough. It was an absolute lesson learned to do the work where the work is being done and not as a separate activity. Have that conversation with the business. And as a result, I went from 10, 20% conformance to 95% in less than a year. Less than a year. Absolutely knocked it out of the park when it came to conformance with cybersecurity. That was a huge lesson learned.
We love that key lesson, and it's the perfect note to end our conversation. Andy, they fondly call you an electrifier at Schneider Electric, and we can definitely see why. Thank you so much for such an insightful conversation. It was lovely to speak to you.
Thank you, Rebecca. This conversation has lived up to all of my expectations. I look forward to hearing the podcast.
Well, that's all from me, Rebecca McLaughlin-Eastham, and my special guest, Andrew Kling of Schneider Electric. You've been listening to a brand new episode of a new podcast series brought to you by the Operational Technology Cybersecurity Center of Excellence under the Global Cybersecurity Forum and in collaboration with Saudi Aramco. Thanks for listening, and stay tuned for more conversations coming soon to Apple and Spotify. Goodbye.